Good morning, students. Today we will discuss about parser of compiler design. So here I will share the screen. Okay. So students, I am Ankur Pandey, Assistant Professor Computer Science in SIT Bhopal, and today's topic is parser in compiler design, which you already studied in the sixth semester. So we will discuss about what is parser, parse tree, syntax tree, and useless symbol, and how to remove useless symbol. Such these are all topics we will cover today. So we move on to next slide. Okay. So here it's outline of the today class and parser, role of parser, and specification of grammar. So first of all, we will discuss about what is parser. So a parser or syntax analysis is a process which takes the input string W and produce either a parse tree or generates syntactic error. So we all know that in compiler actually uh, compile the whole program, whole code from left to right in manner and find out the error if there is available in the program. If there is no error, then we then the programmer can freely run the program and generate the output. So here we have seen that there is some example a equal to b plus 10. So so you can see that a is operand, equal to is operator, b is operand, plus is operator, and 10 is operand. And so we 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 produce a parse tree like that, like operand equal to from left to right a, and then operator plus which addition b and 10. So such type we can produce parse tree. Issues in parsing, specification of syntax and representation of input after parsing. These both are the issues in parsing technique, or we can say in parser technique. Context-free grammar. This is the very important topic in compiler design in QC also. What is context-free grammar? Because we all know that grammar is the set of rules or protocols for any language. If we talk about Hindi, English, whatever language you used in your daily life or in programming, there is some rules, there is some protocol by which the by which the language is generated, and we all human bodies and so society use the such type of language. The context free grammar G is a collection of the following. Actually, there are four tuple V, T, S, P. V is set of non-terminal. Non-terminal value means those value who have like A, capital B, capital C, capital D. In capital symbol, they all are in variable set, and those value who belongs to some numeric symbol, special symbol, or small letter symbol, then they belongs to terminal. So B is the set of non-terminal, T is the set of terminal, S is the start symbol, and P is the set of production rule. Production rule uh, defined for produce some output. We use a production rule. So they are four tuple V, T, S, P. So let's move on simplification of grammar. Uh, we can simplify grammar by some rule like eliminating useless symbol and eliminating null symbol. Simplification can be done by removing useless grammar, elimination of epsilon production, and removal of unit production. So we all know that useless grammar and useless people uh, never nobody wants to in our organization in this earth also. So we same phenomena we use here. We remove useless grammar and eliminate epsilon production and removal of unit production also from the grammar. Then after that we apply parsing technique and produce optimized grammar for our production. Removal of useless symbol. Any symbol is useful when it appears on the right hand side in the production rule and generates some terminal string. sim there is simple mechanism that if suppose that A tends to capital B, and in second step B produce small a, then B is useless. Then B is a useful symbol. And if suppose that A tends to B, capital B, and B produce capital C, then B is use B is useless symbol now, because we all want terminal. We all want terminal in our production. Terminal is just like that. Terminal is just like our home. We back up in morning, go to our office, go to for our work, and evening in night we return to our home. Then home is our terminal. This is the destination. We can also take the example of like trains, aeroplane flights. They all move from source to destination, and there is some terminal point where they can stop and rest for some time. So such type of phenomena we use here, when it appear on the right hand side and produce some terminal value, then it's useful for us. And if don't produce a terminal value, then it is useless for us. So we took an example: S tends to AB, BX, A tends to VAD, BSX, Q, B tends to ASV, BVX, and X tends to SBD, AB, ABX, AD. Find so first of all we will find out the those production who drive terminal value directly or indirectly. So here we filtering for terminal value. S tends to AB, B produce capital, and BX. So here we got the terminal value, so we pick up this value S tends to BX, and now second step, A tends to Q, B can pick up, and X tends to AD, B can pick up also this value. So in first step we pick three production from all of 1, 2, 3, 4, 5, 6, 7. From 9 to 10 production we pick only three production. Which drive to terminals. And let's move on. So assets are capable of driving set of terminal, hence B can be limited from the grammar. We can eliminate production of B. Again, we conclude we cannot drive our non-terminal of A, so A is useless finally, because here S tends to BX, and X tends to if we replace X to AD, X to AD, we can replace X to AD. So what is the use of A production? So we can't use A in our derivation, in our finding the terminal value. So we can eliminate A also, and we got S tends to BX and X tends to AD. Next is the consider the grammar and obtain equivalent grammar containing no useless grammar symbol. So here is the example also. A tends to XYZ, capital X, Y, double Z, XZ. So we also use the phenomena of useless symbol, removal of useless symbol, removal of unit production, removal of null production here to obtain the useful grammar, useful production. So there are two derivation: A tends to XYZ, Z tends to Z, are capable of driving elimination production of X. And so such type of we can find out the simplified grammar. A tends to XYZ, then this is the grammar. Elimination of epsilon production, because epsilon production, if we got epsilon in right side, then we can eliminate because there is no use of epsilon production. If any grammar contains epsilon production, that can be eliminated, changing the meaning of a grammar. If A tends to epsilon is a production to be eliminated, then we will look for all production having A on the RHS and will replace with epsilon. S tends to small a, capital A tends to small b, epsilon. To eliminate A tends to epsilon, replace A with epsilon. So we replace A with epsilon, and then we got S tends to, here we put a capital epsilon in the position of capital A, so we got S tends to A, and then S tends S tends, now grammar will be S tends to A, capital A, and A tends to B. Now there is another example of removal of epsilon production. S tends to 0s, 1s, epsilon. To eliminate epsilon production, replace S with epsilon. So we put epsilon here, so we got 0, and we put epsilon here, so we got 1. So this is our final production, final grammar. S tends to 0s, 1s, and 0, 1. Removal of unit production, this is the terminal production got another non-terminal production. Okay, so we can, if we want, we can recap this. The unit production and the production in which non-terminal produce another non-terminal. So we can take an example like that. A, capital A, which is non-terminal, produce A tends to capital B, which is also non-terminal, and B directly and indirectly not produce any terminal value. So such type of production called unit production, and you can simply remove such type of production from the grammar. Okay, and so this is for the this is and for today. And if you have any problem, then you can text me, you can mail me, and you can also ask to in class also. Thank you to all students. Thank you.